guys, welcome to calculus. Are you ready for this? It's actually not as scary as you think. The first couple sections are actually review, so we're just going to review some very basic things that you already know. We are going to go a little bit fast, so if you're struggling, you've got to come in and you've got to review these things with me. These have to be very solid. You should be able to do this stuff in your sleep, because this is stuff we're going to revisit over and over and over in calculus. So if you don't know how to do it, you're going to feel like you're drowning. But once you get this stuff, we just have to pull it from, way back here in our brain. We just have to pull it out and remember it, okay? And once you remember it, you're going to be golden. It's going to be totally fine, okay? So the first concept we're going to talk about is slope. So easy, right? We know about slope. We've been doing slope since like forever, okay? But there's some things in calculus that we want to remember about slope. So let's talk first about what is slope. Well, we know slope can sometimes be represented with the letter M. It also, we could be rise over run. That's the other thing, how far up did we go by how far over did we go, which is the same as this. This one I know a lot of you guys get tripped up on. It's just y2 minus y1 over x2 minus x1. This just means, hey, let's take where we ended and we're going to subtract where we started. So we're going to find the distance between where we ended and where we started on the y, and then we're going to divide that by the distance between where we ended and where we started on the x. And we're just going to make that into a fraction. So that's all that this is. Remember, this is the change, the distance between these two. How much did this change from when it started to when it ended? That's what this triangle means. It means delta. We call it, it's the Greek letter delta. It means change in y over change in x. So all of those things represent slope. But this is what you really need to remember about slope for calculus. The one thing you really need to remember about slope is that slope is rate of change, okay? It's how fast something is changing. And that's basically it. That's all that slope is how fast is it changing. And we remember rise over run. So we're figuring out how fast is the y changing in relation to how fast the x is changing. So you might also, let's look at this in a real world example. So here is a graph of how many friends you have in a year of high school. Now, you start out freshman year with like a ridiculous number of friends. You got 20 friends, right? And you're just like the most popular person in school. And then the next year, you decide some of those friends are super fake, so you get rid of them, and now you only have 15 friends. And then the third year, you're like, man, I got a job, I got homework, I'm just going to keep the 10 best friends that I have. And then in the fourth year, you go down to just 5 friends because you're like, these are the people I actually want to, be friends with for the rest of my life. So we have this line that represents how many friends you have in a year. And let's pretend that's straight because Mrs. Barney always draws straight lines, always. So what is the slope of this line? In other words, what's the rate of change? What are we looking at? We're looking at the rate of change of friends in relation to years. So how many friends per year? So that's what our slope is going to tell us. The rate of change of friends every year. How many friends do we gain or lose every year, right? And it looks like we go down 5. We went down 5 and we went over 1. So down 5 would be a negative 5, right? So what's the slope of this line? The slope is negative 5. We can figure that out. But what does it actually mean? What does it mean? It means that I have negative 5 friends per 1 year changing, right? The rate of change of friends is negative 5, which means I'm losing 5 friends each year, okay? So that's what slope means. It's the rate of change of anything that we're talking about, okay? Slope is rate of change. So let's figure out how to actually find slope. You guys know how to do this. You have a graph here. You can just count it, okay? So it might be just taking a minute to think. Come on. Show the graph. No? Okay, it's not showing a graph. So I guess we're going to go to number 2. Oh, there it is. Ooh, it caught up with me. Okay, here's our graph. We can just count this. We can figure out how many it changed. How far did the y change, right? So if this is, these ones go into the negative, so it's hard to come up with a real world example, but your bank account or something goes into the negative. So y went down 1, 2, 3, 4, right? So the y changed negative 4. And how much did the x change? It went positive 3. So what's the slope of this line? Negative 4/3. Okay. Rise over run. All right. We should be pretty good with that. All right, if we have 2 points, we could just use our formula y2 minus y1 over x2 minus x1, or we could just figure out how far did these change, right? How far is it in between if I go from either one of these points, as long as we start with 1. If I start with 0 and I go to 2, how far did I go, right? I added 2, right? So that's positive 2. If I start at negative 2 and I get to positive 4, how far did I go? Well, I went 6, right? So the slope of this line is 1/3. You could have graphed it. We could have done y2 minus y1. So that one would look like this. 2 minus 0 over 4 minus negative 2, which is 2 over, and then 4 minus negative 2 is positive 6, so it's positive 6. So either one of those works. I just like to think of it in terms of like how much did we actually change, because, you know, rate of change. So how much did we change if we went from 2 to 2? Well, we changed 0, right? We didn't change at all if we went from 2 to 2. How much did we change if we went from 3 to 2? We went negative 1. Okay, so what's the slope of this line? Well, remember, this is okay. This is not okay. We can't divide by 0, but we can have 0 on the top, right? So 0 divided by anything is just plain 0. So this has a slope of 0, which would mean it's a horizontal line, right? The slope of 0, it doesn't change at all. The rate of change of this is 0. This is like every year you just kept your 2 friends, right? You didn't change at all. Constant. Okay. Last one. Slope of this line, again, you could use y2 minus y1. We'll do that one this way. Okay, so y2, 5 minus y1, which is 2, over 3 minus 3. Okay, so we have 5 minus 2, which is 3, 3 minus 3, which is 0. Uh-oh. When we divide by 0, the world blows up and kittens die and all sorts of things. I don't know. But we can't divide by 0, right? We can't divide by 0. So this has an undefined slope. This is not a 0 slope. This is an undefined slope. Remember that. And what does the undefined slope look like? Well, it means vertical, right? It like, the rate of change is undefined. We can't really talk about it because it doesn't change every year. It's like you just stayed a freshman for your entire life. So like years don't change. You just stay there, right? And nothing, your time doesn't go, right? So there can't be a rate of change. I probably just confused you more with that. So just undefined. There we go. Remember, the parallel lines have equal slopes, meaning their slopes are the same, and then perpendicular lines have slopes that are opposite reciprocals. So opposite reciprocal means we flip it, that's reciprocal, and we change the sign, right? So if, in this case, the first, we want perpendicular lines, this line has a slope of 5/2. If we want to find the perpendicular line, we flip it, so it becomes 2/5, and we change the sign, so it's negative. All right. The most important and only form you will be using most of the time ever. You'll still see slope-intercept, you'll still see general or standard forms sometimes, like once in a while. But I'm telling you, if you hate point-slope form, learn to love it, all right? Find its good qualities. Take it on a date and find a little bit that you like about this, because you're going to have to use it. Point-slope form is really the only form we use from now on. So remember, this is how we do it, right? I like to write it color-coded. So the form is going to look like this. Y minus y1, right? And this is any, y1 is any point on your graph, okay? And then it's going to be equals m, which is the slope of our line, times x minus x1. So remember, everything that's purple is going to be a number in your actual equation. It's actually going to be a number. It's not going to be just like a letter. And then everything that's black is going to stay a letter, right? So in the end, you're going to have y minus some number equals some number times x minus some number. Okay, anyway, find the equation of the line described. Okay, so we have a line, or we have a slope, and we have a point. So what do we have? Oh, point-slope form. You're right. That's so easy. Okay, so y minus y1, which is the coordinate of the y coordinate of the line we're given, equals m, which is the slope, -3 times x minus, and then x1, which is the x coordinate we're given, which is 2. You're done. You don't have to do anything else. None of this changing it into standard, none of it changing into like slope-intercept. You're done. That's the equation of the line. Okay? A vertical line through the point negative 1, 2. Well, a vertical line is going to have an undefined slope, right? So we have to think about this. What does that mean? Vertical line through the point, oh, I drew it in the wrong spot, negative 1, 2. So it goes through this point right here. So what is this? Is this a y equals something, or is this x equals something? Well, it's x is always, always, always equal to negative 1, right? Because it's vertical. The y changes, right? Y can be 0, y can be 1, y can be 2, y can be 3, y can be negative 1. But the x doesn't change. So this means x is always equal to negative 1, so it's just x equals negative 1. A line through this point parallel to this graph. Okay, so we first need to have a slope, and then we're going to put in the point. So the graph 2x minus 5y equals 5. We don't know the slope of that right now, so we got to put it in the slope-intercept form to find the slope. So we're going to subtract 2x from both sides, so we have negative 5y equals negative 2x plus 5. Divide by negative 5. And you have y equals 2/5 x minus 1. So the slope of this line is 2/5, right? And since we're finding a line that's parallel to that line, we're just going to write that same slope. So y minus 2 equals 2/5 x minus 1, negative 1, which is plus 1. It says we need to get into point in slope-intercept form, so let's just go ahead and do that. So we're going to do y minus 2. That's going to be 2/5 x plus 2/5. And then we're going to add 2 to both sides. So we have y equals 2/5 x plus, let's see, that would be 10/5 plus 2/5 is 12/5. So there you go. That's in slope-intercept form. Now we're doing a line that's perpendicular to that same graph, and we have that point. So we know that the slope of the line is 2/5, right? This isn't right. Okay, 2/5. So a perpendicular slope would be the reciprocal, which means we flip it, and the opposite. So negative 5/2. So we're going to need a line that has a slope of negative 5/2, and so that goes through the point negative 1, 2. So that's y minus 2 equals negative 5/2 times x minus 1, negative 1, which is plus 1, and they want it in general form this time. So we just need to get the x and y on the same side. So we're going to add 5/2 x plus y equals, we're going to add 2 to that side, so we're going to end up with 12. Not 12 halves. See, I had 12/5 in my brain before. So that would be 4/2, and negative 5/2 is going to be negative 1/2. Okay, now here's the thing. General form, remember, you can't have any fractions in it. So we got to multiply everything on this side and everything on this side by 2. So we end up with 5x plus 2y equals negative 1. All right, now we're going to draw the graphs of these lines. So there's a couple different ways. This one is in standard form. And in standard form, we can do the cover-up method, which is actually really easy. Because we can just say, okay, what happens when x is equal to 0? What is y? Well, I can solve this for y. 3y equals 9. That means y equals 3, right? So when x is equal to 0, which is right here on the y-axis, y equals 3, right? So I know that this is a point on the graph, okay? And then I can do the same thing. I can say what happens when y is equal to 0. When y is equal to 0, I have x equals 9/2, which isn't as great, but we can do it. So 1, 2, 3. Oh man, it goes way out here. That's not perfect, but the cover-up method is really the easiest, and usually your graph will have plenty of space. The other way we could have done this is we could have gotten it into slope-intercept form, and we could have just found the slope and the intercept and done it that way. Let's go to this one. Y equals 2. Done. That was easy.